Hello guys, we're gonna continue with first principle. In first principle, okay, write the formula, we both know it, eh? And then we're going to deal with trig functions, and then for trig functions you need to know these identities. And let's minus. Maybe you know it's a minus. Can I should write them? Video. So then here we're doing an example which is f of x is equals to sine x, right? F of x being equals to sine x. So with that, still we're going to do the same thing. We need f of x plus h. We write the formula first, which says that it's lim as h goes to 0 of f of x plus h minus f of x, everything over h. So then we need f of x plus h and f of x. So we're going to take f, and then in terms of x, we're going to put f of x plus h, x plus h. Then we're going to have sine x plus h. Then f of x still it will remain the same, which is sine x. Yes, and then we have to plug in. That is lim as h goes to 0 of f of x plus h, which is sine x plus h, minus f of x, which is sine x, everything over h. And then with that we are going to have with that we're going to use these identities. Sine x plus h, we're going to use this part, which means that we're going to have f prime being equals to sine x, lim as h goes to 0 of sine x cos h plus sine h cos x minus sine x, everything over h, remember. So now from here, what you're going to do, we are going to, let's distribute this h over this term and this term and that term, cause so that we can evaluate each at a time. Sine x cos h, please, this is not cos, it's cos, and yeah, then over h plus sine h cos x over h plus minus sine x over h. Put brackets to show that this limit still is affecting all of them. So then from here, what you're going to do, you're going to have, and now we are going to evaluate. We are going to evaluate each of them individually. So that is, we're going to distribute this lim. But before that, we need to take this sine x. We need to take this sine x over h here, because here we are going to evaluate. We're going to use those things that we know are the limit. Those identities that we know are the limit. Lim as x goes to 0 of sine x over x is equals to 1. Those ones, we're going to use them. And then here we are having sine h over h, and h is going to 0. We're going to have 1 here. This one is independent of h, so it will remain as it is. Here we need to do something about it, because we don't have an x beneath, and here is not h, so we need to see what to do with it. And here we are having cos. Remember, cos x minus 1, everything over x. So we should have something of that sort. So therefore we have to take this and combine it with this one. So that is, we're going to have lim as h goes to 0 of sine x cos h minus sine x. Okay, it's everything over h here, then plus sine h cos x, everything over h, right? So from here I'm going to factor out sine x, because sine x is independent of h. So therefore, okay, let me split the limit for all. This one I'm gonna give it a limit, and then this one as well. So therefore we're gonna have lim as h goes to 0 of sine x. What I said, that I'm gonna pull sine x out, so beneath I'm going to remain with cos h minus 1, and then I can say everything over h, right, plus lim as h goes to 0 of still it's the same, cos x sin h, everything over h. So therefore from here, what I'm gonna do, so now I'm going to pull that sin x out. I'm going to pull that sin x out because it's independent of h. So I'm going to have sin x, sin x times lim h goes to 0 of cos h minus 1 over h, plus I'm pulling cos x out, cos x of lim h goes to 0 of sin h over h. Then from here we should remember that we are having those identities, right? That lim as h x goes to 0 of sin x over x is equals to 1, and lim as x goes to 0 of cos x minus 1 over h is equals to 0. These ones we know them. We know this should be x here. So we know them. So this one relates to this one, and this one relates to that one. So therefore we're going to have here, you're going to have a 1, and here you're going to have a 0. So therefore now our answer is going to be sin x times a 0 plus cos x times a 1. Therefore our answer will be cos x. That will be our answer. And we know that when you differentiate sin, we get cos. This is where it is coming from. And then still for cos, we're going to do the same thing. Let's do for cos. Example 2, that is y being equals to cos x. So we're going to have, okay, that formula, we know it, right? Never say you're tired of writing lim and then you leave it. They'll mark you down. Everything over h. So here we need f of x plus h, which is going to be cos x plus h, and then f of x is going to be cos x. So yeah, then we plug them in. That is lim h goes to 0 of f of x plus h is cos x plus h minus cos x. I never did it before, I don't know how it will look. Then still we're going to use this identity. We're going to use this identity. So that is cos a plus b. So I'm going to replace cos x plus h with that identity, which is cos x cos h minus sin x sin h minus cos x. Yes, everything over h. Still let me distribute. Remember here I'm not putting brackets because I'm having the division sign connecting all these things to show that they are one term, or it is one term. So then still I'm to have cos x cos h divided by h minus sin x sin h divided by h minus cos x, everything over h, and then bracket to cover them up, or to make them 1. H goes to 0. Take this and this, combine them, and pull out cos. So I'm going to have cos x times cos h minus 1 over h, like we did before, and then minus sine x sine h over h. So we're going to have that. So now we can pull those that are independent of h out. Distribute, let me say. Here I'm distributing, h goes to 0 of cos x times cos h minus 1, everything over h minus lim. H goes to 0 of sine x sine h over that. And then those that are independent of x, we pull them out. So I'm gonna have what? So we're starting with, it was cos. We're gonna have cos x of lim of cos h minus 1 over h. Remember, it is going to 0. And then we have minus sine x times lim as h goes to 0 of sine h over h. By those identities, we know that this is a 0 and this is a 1, right? This is a 1 from that thing, that lim, as x goes to 0 of sine x over x. It's 1, and then this one is that because of that thing which says lim h goes to x x of cos x minus 1 over x is equals to 0. So we're going to have, our solution is going to be cos x times 0 minus sine x times 1, which means that our answer is minus sine x. And you know that when you differentiate cos, we get minus sine. So that is it. So next video we're gonna do continuity. We're gonna do continuity and differentiability. Yeah, here it is. Continuity and differentiability. So okay, this is it. This is it. Yes. And then we have tangency. No, it's fine. Let me leave it. I'll deal with it.